Overview of the greenhouse effect. The greenhouse effect significantly impacts global temperatures and climate patterns due to increased carbon dioxide levels. The greenhouse effect is a warming phenomenon in Earth's atmosphere caused primarily by elevated concentrations of carbon dioxide. This effect occurs when CO2 absorbs and re-emits infrared radiation, preventing heat from escaping into space. Currently, the atmosphere contains approximately 330 parts per million of CO2, which is rising due to human activities, particularly the combustion of fossil fuels. CO2 increase and its implications. The rise in CO2 levels poses significant challenges for climate stability. Since 1958, CO2 levels have been monitored at key locations, including the Mauna Loa Observatory and the South Pole. Studies indicate that the concentration of CO2 has increased by about 10 to 15% due to fossil fuel combustion. Projections suggest that if current trends continue, CO2 levels could double by 2075, leading to a temperature increase of 2°C to 3°C globally, with even greater increases at the poles. This warming could disrupt weather patterns and agricultural productivity, potentially benefiting some regions while harming others. Climate modeling challenges. Understanding the complexities of climate modeling is crucial for accurate predictions. Current climate models face significant challenges in incorporating all relevant feedback mechanisms. The most accepted models predict that a doubling of atmospheric carbon dioxide would lead to a temperature rise of 2°C to 3°C. However, these models often fail to account for critical interactions such as cloud cover and ocean-atmosphere exchanges, which complicate predictions. The scientific community recognizes that more research is essential to refine these models and improve the understanding of climate dynamics, feedback mechanisms, and natural variability. Natural processes and feedback mechanisms add layers of complexity to climate predictions. The increase in CO2 is primarily attributed to fossil fuel combustion, but there are uncertainties regarding the role of natural carbon sinks such as oceans and forests. Some scientists argue that changes in these natural systems could also contribute significantly to atmospheric CO2 levels. Historical temperature variations suggest that natural climate fluctuations have occurred over millennia, complicating the ability to distinguish human-induced changes from natural variability. Future research directions. Immediate research initiatives are crucial for addressing the greenhouse effect. The U.S. Department of Energy has identified a critical 5 to 10-year window to gather necessary data on the greenhouse effect. Proposed research initiatives include carbon output assessment, evaluating fossil fuel CO2 emissions globally, biosphere contributions, using carbon isotopes to assess biospheric inputs, monitoring expansion, enhancing CO2 monitoring networks for more comprehensive data collection. These efforts aim to clarify the sources of CO2 and improve climate models, ultimately guiding policy decisions on energy strategies. In summary, the greenhouse effect is a pressing issue that requires immediate and sustained scientific inquiry to understand its implications fully. The interplay between human activities and natural processes will shape future climate conditions, necessitating proactive measures and informed decision making. Summary, balance, paragraph, all pages. The greenhouse effect, understanding its implications. The greenhouse effect is a critical phenomenon impacting global climate, primarily driven by increased carbon dioxide levels in the atmosphere. Overview of the greenhouse effect. The greenhouse effect refers to the warming of the Earth's atmosphere due to the accumulation of greenhouse gases, particularly carbon dioxide. Currently, the atmosphere contains approximately 330 parts per million of CO2, which plays a significant role in trapping heat. While CO2 does not absorb much incoming solar energy, it effectively retains the infrared radiation emitted by the Earth, leading to a warmer, lower atmosphere. CO2 increase and its sources. Historical monitoring since 1957, CO2 levels have been monitored at various remote locations, including Mauna Loa Observatory in Hawaii and the South Pole. These observations indicate a consistent increase in CO2 levels. Fossil fuel combustion. The rise in CO2 is largely attributed to fossil fuel combustion. It is estimated that between 10% to 15% of CO2 levels have increased due to human activities, with over half of the emissions remaining in the atmosphere. Predictions for the future. Research predicts that if current trends continue, CO2 concentrations could double by the year 2075, assuming a consistent growth rate in fossil fuel consumption. This increase in CO2 is expected to lead to a global temperature rise of approximately 2°C to 3°C. The effects may be even more pronounced in polar regions where temperature increases could be 2 to 3 times greater than the global average. Potential climate impacts. The implications of rising temperatures are complex and uncertain. Some potential outcomes include altered rainfall patterns. A warmer climate may lead to increased rainfall overall, but it could also shift the distribution of rainfall, benefiting some regions while harming others. Impact on agriculture. Changes in temperature and precipitation patterns could disrupt agricultural productivity, with some countries potentially benefiting while others face reduced yields. Polar regions' increased temperatures may lead to reduced snow cover and melting of floating ice packs, although significant melting of polar ice caps is not anticipated in the short term. Research needs and challenges. Current climate models face several challenges. Inadequate feedback mechanisms. Many models do not fully account for feedback interactions that could influence climate outcomes, such as cloud cover and ocean-atmosphere interactions. Uncertainty in natural carbon cycles. There is considerable uncertainty regarding how natural processes, including ocean absorption and biospheric interactions, affect atmospheric CO2 levels. Need for comprehensive research. Scientists emphasize the need for further research to validate assumptions about CO2 sources and to improve predictive models. Conclusion. In summary, the greenhouse effect is a significant driver of climate change, primarily influenced by human activities. As CO2 levels continue to rise, understanding its implications on global temperature, weather patterns, and ecological balance becomes increasingly critical. Enhanced research efforts are essential to address uncertainties and develop effective strategies for mitigating climate change.